Hello everyone, we'll present a framework for locating superspreaders through the partnership of anonymization and encryption. Contact networks are one of the most reliable data sources for mitigating the spread of pandemics through identifying key people to vaccinate or quarantine. Contact tracing involves identifying potential contacts among individuals in a population to form a contact network. A key concern is that information from contact networks can be misused to obtain confidential data. We propose an architecture which leverages multimodal privacy in order to enable effective mitigation of pandemic while protecting citizens' personal data. Data enablers and contact tracers produce contact network to be used by data scientists and policymakers. Data scientists need to know the configuration of the network to develop advanced algorithms for finding key people to vaccinate or quarantine. The networks are anonymized to enforce privacy. Policymakers need precise details to make the decisions but need not access the network directly. The data is encrypted and algorithms developed by data scientists is used as a black box. Our proposed architecture will enable continuous flow of information between these two groups. Scientists will be aware of new information while the officials can leverage the novel algorithms created by the scientists. Anonymization of contact networks. Contact networks are dynamic, that is, they change with time, and noisy, that is, they contain spurious or missing edges, here given in red. Once the contact network is created, we represent it as a graph. It is possible to identify a vertex with its corresponding person by observing unique properties of the vertex. Anonymization is applied to reduce the number of vertices with unique properties. Our proposed anonymization techniques are designed to be scalable on large networks, can handle dynamic data, and are resilient to noise. As can be seen, in this anonymization, no vertex in the anonymized graph has unique properties that make it distinguishable. However, the information that A and B are superspreaders is retained. Encryption of contact networks. To enable information service to the policymakers, the contact network will be protected using advanced encryption techniques and placed into the cloud. The superspreader and community detection algorithms will be run as a black box over the encrypted data. Officials can obtain answers without seeing the contact network itself, such as if you ask who are the superspreaders, the answer is A and B. If you ask which group has the most spreaders, the answer is A, B, and D. To summarize, the contact network is used by algorithm developers to create algorithms for identifying communities and superspreaders. The entire network is needed, but personal data is not required, thus we can anonymize it. On the other hand, policymakers need this data to make strategies for vaccinations and quarantine. They need personal information, but algorithms are a black box. They can work on encrypted data. The two groups should be able to seamlessly communicate with each other. Our framework facilitates continuous dialogue between scientists and policymakers while preserving privacy of the contact information data and can handle noisy and dynamic data. This framework can be applied to any application that requires secure data sharing among different groups, including mobile network security, customer security, and military information. That's it for now. Thank you for your attention.